Hello guys, my name is Matthew Lewis, and today I will be talking about static friction. Static friction is a friction force that keeps an object at rest. For example, if I apply a small force to this AP Physics 1 Essentials book, it will not move. This is because of the static friction between the book and the wood table. Let's make a free body diagram of this situation. Here we have the AP Physics book. First we have the downwards force of the mass of the book times gravity, and we also have an equal and opposite normal force. Next we have the applied force from my finger and the resulting static friction force that is equal and opposite. There's also a point that if I apply enough force to the book, that the book will move. When I was in the process of moving the book, the applied force was larger than the force of friction, which opposes motion. This phenomenon is called kinetic friction though, not static friction. Next we're going to calculate the minimum amount of force that can be applied to the book for it to change from experiencing static friction to kinetic friction. The book weighs approximately 1.2 pounds, or 0.544 kilograms. The estimated static friction coefficient between the plastic cover of the book and the wood table is approximately 0.3. We now have the information needed to solve this problem. We use this formula derived from Newton's second law, which states that the minimum force needed is equal to static friction coefficient times the mass of the book times gravity. Using these values in this equation, we can see that the minimum amount of force needed to move the book is 1.60 newtons. So now you know how to do a simple problem involving static friction. But what is a real-life application of static friction, you may ask? One application of static friction, which you use on the way to school every day, is the wheel. The wheel relies on static friction to move the car. This beautifully drawn circle represents a wheel, which is sitting on top of the road. When the car wants to accelerate, the engine exerts a torque force on the wheel. Instead of just spinning though, because of the static friction at the contact point between the road and the rubber tire, the applied force from the torque is not enough to overcome the static friction coefficient, creating an equal and opposite friction force, which causes the wheel to roll forward, taking you to your destination. And that's the end of my video, you guys. Thanks for watching.